Alright, so this is your video on solving log equations. We're just going to do some examples and then you'll have some practice to work on your own. So for our first equation, we have log base 17 of 5b minus 10 equals log base 17 of 4b. Now this is just like with exponents. If the bases are the same, then you can just set the insides equal. Just like with exponentials, if the bases are the same, then you can set their exponents equal. So we're just going to set the insides of these equal. So we have 5b minus 10 equals 4b. You guys probably know how to solve this. I'm going to subtract 5b from each side and divide by a negative 1. So you should get 10 for your answer. Now the thing about logarithms, if you remember yesterday when we graphed them, they have domain restrictions, right? So there were times when the domain was not all real numbers, it was greater than 0 or less than 0. So with these equations, you have to check your answer. So you're going to want to go to your calculator and check. We'll try to get that glare off there. We'll go to Math, down to your log base symbol. I'm going to type in, log base 17 Well, I didn't intend to do that. Let's try that again. Log base 17 of 5 times 10. We're substituting our answer, minus 10. And I'm going to do the same thing for the other side just to check and make sure that they do give me the same answer. And they do. So I see that my answers match. I have checked. This is fine. There will be times when your answers don't match, and you'll know that that's not really a solution. Our next example is really similar. Again, I've got log base 3, log base 3. Anytime the bases are the same, we can just set the insides of our logarithms equal. Now the difference with this one is because of the square, that's a quadratic equation. So you may have to remember how to solve quadratics. Remember, we need all of our terms on one side, so I'm going to subtract 5a from both sides and add the 3 to this negative 9 to get a negative 6 and solve from there. You've got options. You can use quadratic formula. I'm going to factor. So this should factor to a minus 6 and a plus 1. Set my factors equal to 0. Sorry, a minus 6 equals 0. A plus 1 equals 0. So I get two answers. A equals 6. A equals negative 1. Now you need to check both of those answers. So if I plug in 6, see, I got log base 3, 5 times 6 minus 3 for my left side, and log base 3 of 6 squared minus 9 for my right side. I see that 6 does indeed work. And then I'm going to do the same thing, except I'm going to plug in negative 1. So this time, log base 3 of 5 times negative 1 minus 3. Let me insert a negative there, make sure all of my bases work right. And that's a problem. So I've gotten an error because that's not in my domain. So negative 1 does not work. So the only possible answer here is 6. Now we need to talk about what you do if there's not logs on both sides. So I'm still trying to solve. My first step is going to be to get that logarithm by itself. I need to isolate it. So I'm going to subtract 4. So 22 minus 4 gives me 18. And divide by 9. This is 9 times log base 3. 18 divided by 9 gives me 2. Now from here, this is one of those situations where it's good to be able to rewrite. So I'm going to rewrite this as an exponential. The base is 3. The power would be 2. And it equals k. Now that's something that's fairly easy to solve. Looks like k should be 9. You're going to want to check that on your calculator, but it should work for you. Now for our last example, same idea, a couple more steps. I still need to isolate the logarithm first. Now all this in the parentheses is inside the logarithm. You can't move it yet, but I can divide both sides by 9. Which puts me here. Now at this step, I've isolated the logarithm. This is when I rewrite it to an exponential. Base is 12, power would be -2, and it equals everything inside the logarithm. Now this is something you should be able to solve. I can't promise your numbers will always be pretty, but you've got your calculator to help you. You can do this in your calculator if you need to. 12 to the -2nd should be 1 over 144. We do want to stick with fractions here. To solve for r, I'm going to subtract 9, which again, do this on your calculator. I know that's a big number. You should get negative 1,295 over 144. And then divide by -4 for a final answer of 1,295 over 576. Now again, you need to check that, so use your calculator, plug this back in for r, but again, you should find that it works. So this has been Solving Log Equations. Try some problems on your own, and I will be back to answer questions. Have a good day.